प्यारे बच्चों, today we will discuss input and output resistances in feedback amplifiers. How we can control input and output resistances by using proper feedback topology. We have four types of topologies for four amplifiers. According to topologies, we have different input and output resistances. Topologies are, first one is series shunt, second one is shunt series, third one is series, and last one is shunt. These four topologies are used in four different amplifiers. First one is voltage amplifier, second one is the current, third one is the transconductance, and last one is the trans resistance. So we have four topologies, and for first one, that is for series shunt, we have input and output resistances for feedback amplifier. Suppose we are using series shunt amplifier, so then resistance is given by 1 plus area, and for shunt this is divided by 1 plus area. Obviously these are input resistance for basic amplifier, means without feedback, and this is output for basic amplifier, and these are input resistance and output resistance with feedback. So this is the expression for input and output resistances for series shunt. So these two terms are important, series and shunt. If connection is in series, then resistance is increased, and if connection is in shunt, then resistance is decreased. So at input, connection is in series, therefore input resistance is increased by this factor, which is called amount of feedback. And at the output, connection is shunt, therefore resistance is decreased by the same factor. So if connection is in series, then we have an increased resistance, and if connection is in shunt, then we have a decreased resistance. So in this way, we can control input and output resistances for using topologies. Similarly, for second, third and fourth, we can obtain different input and output resistances. If connection is shunt, then obviously resistance is divided by this term. If connection is in series, then it is multiplied by this term. We will follow the same procedure for all other three topologies. So this is for first one. For second, that is shunt series. Rule is saying at input connection is shunt, therefore this is decreased value 1 plus 8. And at output connection is series, therefore at output resistance is increased by the same value. So this is for second one. Shunt means decrease, series means increase. So this is for second one. Similarly, for third and fourth, we can obtain input and output resistances. For third one, that is series. At input connection is series and output connection is series. Therefore, at input and at output, both resistances are increased by this factor. So we can write for this type of connection. Series means both are increased. Similarly, for fourth one, resist shunt. So at input and at output, because connection is in shunt, therefore resistances are decreased. Original input resistance is decreased by this factor. Similarly, actual output resistance is decreased by the same. So this is the method to find out input and output resistances for 4 different topologies. So main terms are this. What type of connection is there? Whether it is series or shunt. And it will depend upon the amplifiers. Voltage, current, transconductance and transducers. So this is the method to find out the input and output resistances for different feedback topologies. Now we can take numerical problems based on this. You can see. Consider a series shunt feedback amplifier in which the open loop gain is A equals 10 to the power 5 and the closed loop gain obviously this is gain with feedback, this is given 50 and input and output resistances of basic amplifier are 20 kilo ohm and 40 kilo. Determine the input resistance of a determine the input resistance of a series input connection and the output resistance of a shunt output connection for an ideal feedback voltage amplifier. So this is the statement of problem. Consider a series shunt. So this term is important. Series shunt feedback amplifier, in which open loop gain K is given, closed loop gain is given, input and output resistances without feedback is given. You have to determine input resistance and output resistance when we are using feedback. So what is the method? How can we determine input and output resistances when feedback is used? Obviously, input connection is series. At input connection is series, therefore this is given by 1 plus AB. And at output connection is shown. So these two terms are important. So at output this is given by 1 plus AB. Now you can calculate beta from this expression, since AF equals A upon 1 plus A beta. So from this expression you can calculate beta. You can find out beta. Put these two values, value of A and value of A, and you will get the value of beta. Then easily you can calculate all these two values. You will get gain with feedback is 40 mega ohm and output resistance is 20. So after calculation you will get this, you can check. So this is the method to find out input and output resistances. So these terms are important. Which type of feedback we are using. On the basis of that, we can determine input and output resistances. More problem. We are using an operational amplifier here and inverting and non-inverting is given Vs and this voltage drop is here at input is VA. Output is V0. For this problem, we have given input resistance is given 50 kilo, R1 is 10 kilo, R2 is 90 kilo, and gain is given 10 to the power 4. Determine expected input resistance. So this is the statement of problem. So first check what type of topology is used. As input is voltage, output is voltage. Okay. So this is the voltage amplifier. And for voltage amplifier, topology is series shunt. So because mixing and input is in series, two different voltages. One is fed back from the output. This is the feedback voltage. This is fed back at the input, and this is mixed with source. So obviously Vi is the difference of these. Vs minus V2. This is the voltage. You have to calculate input resistance. So at input connection is 6. So what is the input resistance for this problem? So this is given by 1 plus A beta. Now what is given? Ri is given. Okay. A is given. You have to calculate beta. First calculate beta. What is value of beta? By definition, this is the feedback signal upon output. Feedback is this, output is this. And here we are using a potential divider. So V0 is the total drop across combination of R1 and R2. This V0 is the summation of two voltages, drop across R2 and drop across R1. And here is the drop only across R1. So this is the voltage drop across R1 and V0 is the total drop. So we can use potential divider here. So this is R1 upon R1 plus R2. So this is the value of beta. So now we can easily calculate by using these two resistances, and after that we can put values in this expression. Ri is given, A is given. You can calculate beta by using this R1 upon R1 plus R2. Then this is approximately you will get RIF equals 50 mega C. So this is the about input and output resistances. So main term is which type of topology is used. On that basis, we will decide input and output resistance. So rule is simple. If there is a series connection, then resistance is increased by the factor equal to amount of feedback. And if there is a shunt connection or parallel connection, then resistance is decreased by the same factor. So this is the basic rule to calculate input and output resistances for feedback amplifiers. Now you can note few problems for assignment. An amplifier has a voltage gain of 1000. A is given 1000 and F1, this is the lower cutoff, is given 50 Hz, and F2, which is the upper cutoff, is given 200 kilo. And obviously this is without feedback. Means these are values for basic amplifier. You have to calculate F1 with feedback, F2 with feedback, and gain with feedback. Calculate all these three. So you have to calculate this. This is the first problem. Obviously, you know what is the method? I'm giving hint here. When we are using feedback, lower cutoff is reduced and upper cutoff is increased. Here we have a band diagram. Suppose these are two cutoff frequencies. This is F1, F2, lower, upper, and this is F1 with feedback. Similarly, upper is increased, F2 with feedback. So you can calculate, this is increased by the factor 1 plus A beta. This factor is important. Okay. So beta is given in this problem. Beta is given. Beta you can use 0.05. Similarly, you can calculate gain with feedback. So this is the first problem. Second one is an amplifier has a mid-band gain of 200 and frequency response is this, and from 100 Hz to 20 kilohertz. So this is the frequency range. Means lower cutoff is 100 and upper cutoff is 20 kilohertz. Negative feedback is used. Negative feedback is used. With feedback factor 0.02. calculate bandwidth. So what is the method to calculate bandwidth? So bandwidth with feedback is given by upper cutoff frequency with feedback minus lower cutoff frequency with feedback. This is the difference of two frequencies. So these are two frequencies without feedback. So first of all you have to calculate upper and lower 3 dB frequencies with feedback. Then difference. So initial bandwidth that is bandwidth without feedback is simply 20 kilohertz minus 100 hertz. This is the bandwidth. And when we are using feedback, obviously these two frequencies are increased. This is increased and this is lower by the time. So first calculate this term 1 plus A beta, which is called the amount of feedback. A is given, beta is given, A is given in this problem. So you can easily calculate 1 plus A beta, then upper 3 dB and lower. The difference of that is called the bandwidth. One more and last problem. An amplifier has mid-band gain. Its upper and lower cutoff frequencies are its upper and lower cutoff frequencies are 16 kilohertz this is the upper and 40 hertz. So upper cutoff frequency is 16 kilohertz and lower is 40 hertz. What will be the bandwidth? What will be the bandwidth after 2% of the signal output? 2% of the signal output is given as negative feedback. So this is the statement of problem. Mid-band gain is given. Mid-band gain means here. This is the mid-band gain without feedback, and obviously when we are using feedback, this is added by suffix here. So we can calculate this. Gain is given by 1 plus A beta. So these two frequencies are given, upper and lower. What is meaning of this 2% of the signal output? Obviously 2% means beta, which is defined as feedback upon output. 2%. If So we can write 2 upon 100. This is the rate. That is 0.02. So this is the fact. So this is all about feedback amplifiers. So in feedback amplifiers, we have studied basic properties of feedback amplifiers. So by using feedback, we can incorporate following properties. First one is the bandwidth extension. Second one is the increase in bandwidth. One is desensitization of gain. Another is control in input and output resistances. And one is the reduction in signal effect of noise can be reduced. So these are all properties of feedback amplifiers, and we can use any four topologies based on the four basic amplifiers: voltage amplifier, current amplifier, transconductance, and transresistance. Then we have taken few numerical problems. So this is all about feedback amplifiers. In next term we will discuss oscillators. Thank you.